Alright, so this section is absolute value equations and inequalities. We're going to start with the equations first. Write down that definition for absolute value. I think we've already talked about this. And you should remember absolute value of a number is its distance from zero on a number line. So you know distance can never be what?
Zero.
Negative.
Or, yeah, negative.
It could be zero,
Yeah.
because you don't have to go anywhere.
Yeah.
But it can't be negative.
You realize.
Here, we have two examples of absolute value problems. This is the symbol for absolute value, two vertical lines. So this is asking what is the absolute value of -7? How far is -7 from 0? 7 units. That's why it's positive. Same thing here. How far is +7 from 0? 7 units. That's why it's 7.
What is that right there? That is what?
Right here,
Yeah.
it's ITS. Yeah, that T
Looks like 7.
looks a little bit like a 7.
Looks like 175.
Okay. Let me fix that for you. All right. So the problem below, if absolute value of x is 7, then what two values could x be?
Negative 7 and 7.
7 or -7. All right, so this is how we're going to solve absolute value equation. All right. Any questions so far? Right here. The original problem is right there under example. Absolute value of 2y minus 4 equals 12. Solve. Solve for y. What could y be? Basically, it's asking you what number could be in here. So that's why I drew this over here. What number could be inside a set of absolute values to give you a result of 12? What two numbers could be inside this set? Huh? 12 and -12. So in this case, we know that this number right here could equal 12, or it could equal -12. So that's how I get my two equations. So your first step in solving absolute value equations is to isolate the absolute value. It's already isolated. It's already by itself right here. Okay? Next step is to get rid of the absolute value symbols. To do that, we come up with two equations. So from here to here, I get rid of the absolute value symbols. Then you just solve each of them separately. In this case, add 4 to both sides. So I add 4 and then divide by 2. So y is 8 is the first possible answer. Same thing over here. Now once you get here, don't make the mistake of saying, since 8 is an answer, that -8 has to be an answer. That's not true. Alright? Or not always true. Here, add 4, divide by 2, you get -4 as your other possible answer. Check them both out. If I plug 8 in here, what do I get? What's 8 times 2? 16. What's 16 minus 4? 12. What's the absolute value of 12? 12. Over here, -4 times 2, -8, minus 4, -12. What's the absolute value of -12?
12.
Positive 12.
Yeah.
So that's why they both work. All right?
I should see the numbers.
Next, solve 3 absolute value. 4w minus 1 minus 5 equals 10. All right, first step here, like I said, is to isolate the absolute value. The first problem, it was already by itself. Here it's not, so you gotta do a little bit of work. First step, add 5 to both sides to get 15. You cannot distribute a number into absolute value, so don't do that. Here, to get rid of this 3, we divide both sides by 3. All right, another thing you can't do when you get down to here, you can't start adding numbers or dividing by numbers that are inside the absolute value. You have to get rid of the absolute value symbols first. All right, is everybody good up to this point? All right, when I get to this point, to get rid of the absolute value symbols, I have to set up two separate equations. I know that the number inside here could either be positive 5 or negative 5 to give me a result of 5. So that's where I get 4w minus 1 equals 5, or 4w minus 1 equals negative 5.
So if you, as long as you had the absolute value by itself, you take the bars off? Okay.
To get the bars off, you have to set up two equations. That's the only way that the bars go away. All right? And you need them to go away in order to solve. You have to get rid of the absolute value symbols. All right, so here we add 1, we get 3 halves. Here we add 1, we end up with negative 1. So my two possible answers are 3 halves or negative 1. All right, check them both out. What's 3 halves of 4? 6. What's 6 minus 1? 5. What's the absolute value of 5? 5 times 3? 15 minus 5 does equal 10. It works. What about negative 1? Negative 1 times 4? Negative 4 minus 1? Negative 5. Absolute value of negative 5? 5 times 3? 15 minus 5
10.
does equal 10. They both work. Okay. Now there will be some cases where one of them doesn't work, or both of them might not work. So that's why it's important to check your answers. So if you come up with a solution and that solution doesn't work when you plug it back in, then that number is considered extraneous. That's an extraneous solution. So write down this definition. Extraneous solution is a solution that does not work when plugging back into the original problem. And we'll look at this example below. Solve. Absolute value of 2x plus 5 equals 3x plus 4. You do it the same way. We have to isolate the absolute value. It's already isolated. Next step is to get rid of the absolute value symbols. So to do that, you say 2x plus 5 equals 3x plus 4, or 2x plus 5 equals negative 3x minus 4.
Basically, all you're doing when you do the second equation is change the simple side.
Right. You got to take the negative of it, just like we did in the previous example. All right, so we have to solve here. Subtract 2x, you end up with x. So you end up with 5 equals x plus 4. Subtract 4, you end up with 1 equals x as your first possible answer. Over here, add 3x, you end up with 5x plus 5 equals negative 4. So subtract 5, 5x equals negative 9. X could be negative 9/5. All right, this one's easy to check. All right, this one's easy to check, but it's a fraction, so it might be a little more challenging. If you plug 1 in here, you end up with what? What's 2 times 1? 2 plus 5? 7. What's the absolute value of 7? 7. What's 1 times 3? 3 plus 4? 7. 7 does equal 7. And this one doesn't work, and I'll show you why. So if I plug negative 9/5 in, let's do that work. You get absolute value of 2 times negative 9/5 plus 5, does that equal 3 times negative 9/5 plus 4? What's 2 times negative 9/5?
Negative 18.
Negative 18/5
5.
equals, what's 3 times negative 9/5?
Negative 27.
27/5. What's your common denominator on the left?
5.
5, so what does that simplify to?
7/5.
7/5. 7/5, absolute value of 7/5. Okay? And what does the right side simplify to? If 5 is my common
Negative
denominator?
7/5.
Negative 7/5. Okay, and what's the absolute value of 7/5?
7
7/5 does not equal negative 7/5. That is why this is extraneous.
It's because we made the other side a negative number and the absolute value
Correct.
already negative.
Yeah. Okay? But again, they both might work out. Neither one of them might work out. That's why it's important to check your answers.
If neither one works out, does that just mean it's no solution?
No solution.
So then the